Now that we had a look at what React is and why we might want to use it, as well as now that we built our first React app, let's dive into all the core React concepts and the base syntax of React. In this module, we'll have a look at what it takes to build a real React app, and with that, of course, I also mean locally on our machine and not on CodePen. And you will learn which core features React offers and how you use them. So let's dive right into that and let's learn how we set up a local React project on our machine. So we want to set up a local React project. With local, I mean we don't use CodePen, but instead we will have a project on our machine where we can work in with our own IDE or editor. This, of course, is the way we want to work with React. We want to have it on our machine. We have more features available there. It's more convenient than using some web editor. And CodePen, which we used before, or JSBin, which we used in the optional second module, are really more playgrounds than real work environments for real projects. So we will set up a local project, and React is actually more than just importing the two files we imported in CodePen. We need a more elaborate workflow for real projects, and this is recommended for both single-page and multi-page applications. The question, of course, is why do we need a more complex workflow and how do we then achieve it? Let me start with the why. When building a real app, we want to actually optimize our code. We didn't care about this in the demo project in the first course module on CodePen, but for a big React application, we want to ship code that is as small as possible and as optimized as possible, obviously, because that increases the performance of our app. Additionally, and that is super important, we want to use these next generation JavaScript features I taught you about in the last optional module. Now, we want to use that because it makes our life as a developer much easier. And it's the de facto standard for React apps to use all these next-gen features, because the code is leaner, easier to read, faster, less error-prone, and many other reasons. So you should really use these features. It's not just something nice, optional. I strongly recommend using these features. It is considered a best practice, and it is what I teach you in this course, because obviously I want to teach you best practices. So we want to use next generation JavaScript features to have an easier time to write less error-prone code. And with all that, we need a workflow that supports these features. Even on CodePen, we implicitly did this. Remember that preprocessor dropdown where we switched to Babel? That behind the scenes unlocked a couple of build tools that would parse our code and support JSX, this HTML and JavaScript syntax, for example. So we want to use these next-gen features. Essentially, we want to be able to write ES6 or above code and still ship code in the end that runs on as many browsers as possible. And not that many browsers support all these next-gen features. That is why we need a build workflow that actually compiles these features. Finally, in the end, we want to be more productive. This includes next-generation JavaScript features, which often allow us to write more condensed code, but it also includes things like CSS auto-prefixing. You might know that CSS prefixes are a thing to achieve the broadest possible browser support for CSS features. Now, manually adding these prefixes is quite annoying, so automatically adding them is nice. Or consider linting, so a tool which actually warns you if you are writing suboptimal code. That would be nice to have too. Not strictly required, but a nice feature. And all these things should be part of a build workflow. Now, to implement them there, we need a couple of tools that actually let them run over our code, to either warn us in the case of linting, or to compile the code to code that runs on as many browsers as possible, whilst we, as a developer, are writing very modern code that would, on its own, not run on that many browsers. So that's the why. A couple of reasons why writing this kind of code is desirable and why we need a more complex build workflow that actually allows us to write this code, that actually optimizes the code for us. And for that, the how, of course, is relevant. How do we achieve such a workflow? We first of all need a dependency management tool. Dependencies are simply third-party libraries third-party JavaScript packages. React, for example, is a dependency. React DOM is a dependency. And also all the build tools we will need in the end are dependencies. So the compiler for next-gen JavaScript to current-gen JavaScript, that is a dependency. And we will use npm here. Yarn would be another tool you could use, but we will use npm nodes package manager, a tool which just allows us to manage packages and which is the de facto standard for managing dependencies also on front-end projects. Besides that dependency management tool, we need a bundler because we want to write modular code and split it up over multiple files so that each file has a clear task, a clear focus, and therefore is easier for us to maintain and manage. But then we want to make sure that all this code gets bundled into a couple of files in the end when we ship it. Because browsers don't even support split up files, older browsers at least don't do. And it might also, even if they did support it, not be that optimal to make thousands of requests to all these tiny focused files. So we want to have that bundler, and we will use Webpack, which is the de facto standard for bundling these days. The cool thing about Webpack is it doesn't just bundle files, it also allows us to apply a couple of other build steps before it does this bundling. For example, the mentioned compilation of next-gen JavaScript. That requires another tool, Babel. We need a compiler that does this JavaScript compilation, which means translation from modern features to workarounds that also work on older browsers. And we will use Babel plus presets, which can be hooked into the Webpack configuration so that they are part of this bundling and optimization process. And finally, in the end, we want to use a development server to test our app locally on our machine. Development server is a web server, but one running on our machine. We could open a HTML file by double-clicking on it, but this would use the file protocol and would not correctly emulate the app running as it runs on a web server. So we need a web server, and we can of course run one on our local machine. This server is then only accessible by us, but that's all we need as a developer. And there we can really see the app run as it will run in the end on a real server. We need all these things, and it sounds like that's super complex to set up. The good thing is it's not. I will present you a tool that will create a project supporting all these things out of the box with zero configuration in the next lectures. We will install this tool together, and it is a tool created by the React team and community and the officially recommended way of creating new React apps. Because that's the general theme of this course, I will teach you things in the best practice and recommended way. So all of the setup is quite easy. And as a side note, if you still want to dive into how this works behind the scenes and you want to set this up from scratch, I also got a module for that towards the end of the course, where we will build a React app, a React project from scratch. Now with that, you know what we need and how. Now let's dive into that tool I mentioned and let's learn how we actually get started with a new React project supporting all these features. In the last lecture, I highlighted why we want to set up a project which gives us some additional features which make our life as a developer easier. Now, as I also mentioned, there is a tool which creates such a project for us. It's called Create React App, and you can simply Google for it to find a link to its official GitHub repository. As I said, it's maintained by basically Facebook or a community around Facebook. So it's the officially recommended tool for creating React projects. On that GitHub page, you will find installation instructions and a detailed explanation about what it does and how it works. Feel free to read through that, but of course you're also going to learn all about that throughout this course. So let's start with the installation. We install it globally with npm, and npm is simply Node's package manager. A tool you automatically get when installing Node.js, which makes it easy to manage third-party packages, other JavaScript packages in the end, and Create React App is just such a package. To use npm, you need to install Node.js, which you can download and install from nodejs.org. Now there you should pick the latest version, 8.5 in my case here, but if you're facing any issues with that, also try out version 6.11 or whatever the long-term support version is in your case when you're viewing this page. Now, no worries. We're not going to write any Node.js code here. You don't need to know Node.js. We only need it to use its package manager and also for this development server, which will be spun up for us automatically. So simply click these buttons, download Node.js, and it will spin up an installer through which you can walk. Once you did finish the installation, you should be able to run the npm command here on your machine. So let's do this together in the next step. Now to use the Create React App tool, you simply open up a terminal or a command prompt on your machine, and then there you run npm install, and that's what you need Node.js for. It gives you that npm tool. npm install create-react-app. And then important, add -g after this to install it globally on your machine so that you can use this command from anywhere on your machine. Now on Windows you can simply hit enter. On Mac and Linux you might need to add sudo in front of this if you hit enter and get a permission error to get the right permissions. Now after you did hit enter, you're probably prompted to enter your password, and you might want to enter it correctly the first time, unlike I did. But after all of that, Create React App should be installed. Now you can use that command to create a new project, and you do so by running create react app and then the name of your project and of the folder into which it will be installed. Now important, before you run this command, navigate into the path on your system where you want to create that new folder. So here I'm on the desktop, but with the help of CD, you can of course navigate into a different path to store your project there. Then run create react app and then the name of your project, which could be my app or react-complete guide, for example, because that is what this course is about. Now one important note, to get the exact same folder structure as I have it, since this changes over time a bit, and to follow along perfectly, you have to add something to this command. So don't hit enter yet, instead add a white space, a blank, and then add -- scripts version. So this is all one and the same command, even though it's split in two lines here on my machine, but it's one command. So -- scripts version and then a white space and then 1.1.5. Now this does not impact the version of React you're using. You are using the latest version of React, no worries. This simply impacts the structure of the project. We will change that structure throughout the course anyways, but to start with the same, starting point, use this command. Simply hit enter thereafter and a new project will be created for you. So this will now create a new folder and set everything up for you there. You can ignore all the warnings you might be getting here. Everything will be fine, no worries. So let's wait for this command to finish now. And once this is finished, you see a bunch of commands you can run. Now here you see yarn start, yarn build. That is because I have installed yarn, which is an alternative to npm on my machine too. You will also be able to run these commands with npm run start, npm run build, and so on. So first of all though, you have to navigate into the newly created folder. So with cd react-complete-guide if you named the project like I did here. And then in there you can run npm start to start your project. And what this means is it starts a development server which opens a new tab in the browser, or at least it should open that tab. In case it doesn't, you can manually open a browser tab and visit localhost :3000 there. And this is a first project, first demo app that is created for you, which we can now edit. This process here, the npm start process, should be kept on running. Don't quit it. You can always quit it by hitting Control and C. But if you quit it, it will stop watching your files. And as long as it keeps running, on the other hand, it is watching your files. And what does this mean? It means that whenever you change something in code, this page will automatically reload and reflect the latest changes, which is awesome. So as soon as you're done developing, you can quit this. As long as you are developing, keep this process running. Now, with that process running again and that application running here on localhost 3000, let's have a look at the folder that was created and all the files we find in there in the next lecture. In the last lecture, we created our project with Create React App, and as I mentioned, make sure that npm start, this process, is running whenever you're working on your code. I now opened the folder which was created with Microsoft Visual Studio Code. This is the IDE I'm going to use throughout the course, but you can use any IDE or editor you want to use. For example, also WebStorm would be an alternative, or Sublime or Atom, or any other editor you like. Now here I installed a theme and some extensions, and you can find the exact configuration I'm using here described in a PDF document attached to this video, just in case you want to use the same, but feel free to use your favorite setup. Whatever the theme and setup you use, you will have the same amount of files and folders in your project. So let's now walk through all the files and folders we have here. On the root level, we get a couple of configuration files. These log files here can basically be ignored. They're just logging in the versions of the dependencies we're using. The general dependencies our project has are defined in the package.json file. And there you can see we have 3 dependencies in this project. And this was all created by Create React App. As you can see, we obviously import React. Here I'm using a release candidate version of React 16. At the point of time you're viewing this, this should be released. React DOM, it's the same. And React Scripts, as I mentioned, is a package offering all this build workflow, this development server, the next generation JavaScript feature support, and all these things we're using in this project. In the package.json file, there are also a couple of scripts defined. You can run these scripts with npm run and then the script name. The exception is start, which you can also run with npm start, the command we executed. And as you can see, it uses this React Scripts package to then also execute some start command there. That's simply a command this package makes available. And this command happens to start this development server, watch all our code, compile our code, optimize the code, and do all these things. Once you're ready for deploying your app, you would run npm run build to optimize it even more, not launch a development server, but instead get your optimized code stored in a folder, because right now you won't see your compiled code anywhere here. Everything happens in memory. But I'll come back to deploying the application later in the course. So let's close this package.json file for now. The node modules folder holds all the dependencies and sub-dependencies of our project. This is why we have that many. We only had React, React DOM, and React Scripts, but React Scripts has a lot of other dependencies, all these little build tools which compile the code and so on. You shouldn't edit anything in the node modules folder. It's generated automatically if you run npm install in your project folder, and this was automatically done by Create React Scripts. The public folder is more interesting. It's basically the root folder which gets served by the web server in the end, though here it only holds the files we can edit. The script files are edited in the source folder. Here we got one important file, index.html. This is a normal HTML page, and it is the single page we have here. We will never add more HTML pages in this project. If you're creating a multi-page project, you would create multiple such projects here with Create React App. You wouldn't add more HTML files here, or you need your own workflow if you want to do that. So this is the single page where in the end our script files will get injected by that build workflow, which is why you don't see a script import here. And you can edit this file, but we won't write any HTML code here. I want to highlight this div here with the ID root. This will become important because this will be where we actually mount our React application later, and we will of course work in React. But if you need to add any imports to, let's say, other libraries, CSS libraries, or want to add some meta tags, you can do that here in the HTML file. You could also add more HTML here, but again, you probably want to do this in React. The manifest.json file is there because Create React App gives us a progressive web app out of the box, a very basic one at least, and gives us this manifest.json file where we can define some metadata about our application. Interesting for us is the source folder. Here we get a couple of files, and these are actually the files we will work in. This is actually our React application. Most important for us right now, the index.js file gets access to this root element in our DOM, in our HTML file. So the element with the ID root. which of course is this div we saw in the index.html file, this one. And there, as you can see, it renders our React application with the render method. Now here it references some app object or element, which we import from an app file. The extension .js is left out because it's automatically added by our build workflow. And if we have a look at this app.js file, therefore, this is where we see our first and only React component we have in this starting project right now. Here we see some JSX, and I will dive deeply into what we see here exactly in the next lectures. For now, let's remove all the content in this wrapping div, and let's simply add a h1 tag here, where I'll say, hi, I'm a React app. Let's close it, of course, also. And then let's save it. That's always important. Don't forget to save your files. Now, since you have npm start running, this will automatically trigger a recompilation, and it should automatically reload your page too, which is why you should now see, hi, I'm a React app, instead of the old content. With that, we can also remove this logo.svg file because we no longer use it in our project. And now we got a bit of a leaner source folder. Now, what else did create React app create for us? It gave us this app.css file, which basically defines some stylings we use in this app.js file. Though I will say that these are not scoped to this file. These are still global stylings. And I will actually remove everything but this first app class definition in that file and save it thereafter. We also get an index.css file, which also applies styles globally and which should be used for some general setup, as here for the body of our application. The register service worker JS file is, as the name implies, important for registering a service worker, which is generated automatically. That's related to this progressive web app we get out of the box. It will basically pre-cache our script files. We don't need to configure anything there. And the test file, well, we'll dive into testing later in the course. It basically allows us to create unit tests for the different units, for example, components in our application. This is the general setup, and for the majority of this course, we'll work in app.js or other new components we create. Speaking of that, let's analyze this file. Let's understand the syntax we see there. Let's get rid of that logo import because we removed the logo file now that I see it. And let's dive into JSX, what exactly that is, and how we add more components to our application. In the last lecture, I walked you through the folder structure which was created by Create React App, and we edited our app.js file. Let's now dive deeper into what we see here. We see a React component. As I explained, React is all about creating components, basically custom HTML elements, you could say, which you can then use to construct your application. This app component actually gets used in the index.js file, where we render it into the place of this root element. And we could render a normal HTML element here too, test for example. This would work. This is now no React component. If I save this, I see this h1 tag. But of course, then we have no real React application. We're rendering a normal HTML element, but we're not rendering our own React component. Now you could, of course, use multiple React DOM renders and render all the HTML code you want to use in your app. That's not really how you create your React apps though. Typically, you render one root component, the app component, but you can name it whatever you want. One root component, in our case it is the app component, named app, and in there you would nest all the other components your application might need. And of course, these components can then also be nested into each other. But all the way up to the top, you only have one root component. You could reach out to multiple nodes in your HTML file and mount different root components for different React apps all in the same project. That would be possible, but it's not what we do here. In the end, you can of course simply replicate what you learn in this course for multiple applications in one and the same HTML file. But let's stick to the general or typical usage of React. We have this app component, which is defined in the app.js file. Here we see one of two ways of defining a React component. We create a JavaScript class with the class keyword, and then we use the extends keyword to inherit from this component object, or class to be precise, which is imported up here from the React library. Actually, we import two things: React, which is responsible or required for rendering anything to the DOM. We always need to import that in a file where we define a component. And of course, the component class itself. I will soon show you a different way of creating components though. Now, this class has one method, the render method. It needs to have that because React will call this method to render something to the screen. There's one important job every React component has to do. It has to return or render some HTML code which can be rendered to the DOM, to the screen. You can do other things in there too, reach out to the internet, do some calculations, listen to events. Whatever you need in your application, we will see all of that in that course, but you always also need to render some HTML to the DOM. This is so important to keep in mind. We then export this app class as the default export of this file. This is an ES6 feature and simply means if you import this whole file, you simply import this class because it's the default export. We do use this in the index.js file where we import app from the app file. Again, omitting this extension because it's added by our build workflow automatically for JavaScript files. This app name here, by the way, is chosen arbitrarily, but typically you use the name of the component you also use in the file and that you also use as the file name. One side note, you might also see these components with .jsx as a file extension instead of JS. The reason for this is this code here. I referred to it as HTML, which is returned. But in the end, this is not HTML. It looks like it, but it is JSX. So it is JavaScript looking a bit different. And this can be confusing at first when you're learning React. This might be one of the most confusing things actually. Important to know is this is just some syntactical sugar. It was basically invented by the React team, and we can write it in our JavaScript files because of the build workflow we're using here. It will basically automatically transpile it to valid JavaScript in the end. It's not connected to the file extension you're using. It works in .js and .jsx files. And the convention nowadays is pretty much to always use .js files, which is why we do it here too. And it simply is code or a syntax we can use to write HTML in quotation marks, whilst in the end not writing it. Sounds confusing? Let me show you what this actually is compiled to in the next lecture. In the last lecture, I walked you through this component and how it generally is structured. Now let's dive deeper into this JSX thing. For this, I'll comment out this block here so that it's not used anymore, and I'll return something else. I can use the React object we're importing up here and call a method on it, create element. This, by the way, is also the reason why we have to import React, because this code here is in the end compiled to what we're writing here, even though we don't see that. Create element is a method and it takes 3 arguments. Actually, it takes an infinite amount of arguments, but at least 3. The first one is the element we want to render to the DOM. This could be a div. This can be a normal HTML element like a div. It could also be your own component if you have one available here. We don't though, because we're inside a component, we can't render that. We could render any other component we're importing, but we have no such component. The second argument is basically the configuration for this. And there we would pass a JavaScript object. This is optional. We can also pass null, and we'll do this for now because I don't want to configure it. The third argument here then is any amount of children. And we could have multiple arguments separated by commas. Children means what's nested inside this div. Now in this case, we want to nest the h1 element. Let's try by adding h1, and then as another argument, let's add this text here with multiple exclamation marks, and let's escape this quotation mark here with a backslash, so that we can identify that this was rendered by this createElement method. Now with that, let me save this code, createElement with 4 arguments, div, null, h1, and the text. Make sure you save the file. In Visual Studio Code, you see that it is saved if you see a cross here and no dot. And then let's go back to our application. Here we see h1, hi, I'm a React app. And if we inspect this in the developer tools, in Chrome here in my case, which I strongly recommend using, you see we got a div with 2 text nodes inside, h1 and hi, I'm a React app. So we didn't render a h1 element, we rendered text. And this is actually the default behavior. h1 here is interpreted as text. It's not rendered as an element. If we want to render another element inside the div, what we have to do is replace this code here with another call to React createElement to create a new HTML element at the end. Here we now pass h1, then null as configuration, and then the text we want to render. So here let's mix this up and say, does this work now? Now if we save this file and we go back to the application, we see a h1 tag, does this work now? And we can also see this if we inspect it in the developer tools. We get a div wrapping a h1 tag. Now what we don't see is the CSS styling getting applied because we don't see the class being added. In our JSX code, we added a CSS class with class name, not with class by the way. I'll come back to why we use class name in the next lecture. So we add class name. In our createElement call, we will simply not pass null as configuration, but a JavaScript object. And there we can define class name and assign any CSS classes we want to add. For example, app, the same class we're applying here. If we now save this file again, it reloads, and we now see the updated styling with the centered text. And we see the CSS class being applied here on the div too. This is super important to understand. The code we just wrote here with React createElement and the nested React createElement is the exact equivalent of this JSX code. And it's actually to what this code here will get compiled by one of the many build tools we get out of the box in this project. It is the reason why we need to import React even though we're not using it at all when using this syntax, because behind the scenes we will use it once it is compiled. Of course, writing the code like this with createElement is really cumbersome, especially as you add and nest more and more elements. This is why we typically don't use this code, but instead this code we started with. This is the reason why we use JSX, but it's super important to understand the internals and understand what this compiles to, and also, most important of all, understand that whilst it does look like HTML, it isn't. This is JavaScript in the end. It gets compiled to this code. In the last lecture, I had a look at what JSX actually is, and it's so important to understand this. Now, in this lecture, I want to highlight some of the restrictions we face. For example, this class name thing here. JSX clearly looks like HTML, and it should. It should allow us to write HTML-ish code in our JavaScript files. Still, since it is in a JavaScript file, and since it is JavaScript, some words can't be used. Class, for example, which we would use in normal HTML to assign a CSS class, can't be used because it's a reserved word in JavaScript. We already use it here, by the way, to create a new class. This is why we have to use class name. All these elements we can use here, like div and h1, are actually managed or provided by the React library. We are not using the real HTML tags. React is converting them behind the scenes. And React defines the attributes, in quotation marks I should say, we can define on all these elements. And we don't have the class attribute as we have on the regular HTML element. We have the class name attribute here to add a CSS class. As you can see in our final code, this is translated to class though. It's not class name here once it has been rendered. Now, another restriction we face is that when we return something here, let's say we also want to return another heading, we actually can't do this here. Our JSX expression must have one root element. Now, with React 16, this is kind of loosened. And we will see in this course that we can actually return adjacent elements in the end. It is a typical thing and a typical best practice to wrap everything into one root element per component, though this also makes sense since you typically want to style your components and want to add the CSS class, which is responsible for styling, to the root element, as we do here. So typically, you nest everything in one single root element you return. And if you're wondering about these parentheses here, these are simply used so that we can write the HTML. And I'm always saying HTML, but keep in mind it's JSX, it's JavaScript. So that you can return this HTML code nicely structured across multiple lines without receiving errors. This is why we use the parentheses. So with that, I could add a paragraph here where I say this is really working. And let's close it too. Now with that, we see that paragraph here too. And we had a look at some of the restrictions or things to watch out when using JSX. Because again, it isn't HTML, but in most cases, it actually works just like it. We already learned a lot about the core fundamentals of React, especially this JSX thing, which is super important to get right and to understand. But I also mentioned in the first module of the course that React is all about components. You build your application with components, and React is a library which makes building these components so easy. Well, right now, we're only using one component. Time to change this. And for this, I'll add a new file in the source folder of our project. I'll actually even add a new folder, and I'll name it person with a capital P. This is kind of the convention in React. You don't have to do that, but you give your components, the files where you create them, capital starting characters. And you describe what this component is basically there for. And here I want to render some information about a person. Inside that person folder, which is stored in the source folder, I'll create a person.js file. Again, following this convention of having a capital starting character and describing what this component is about. Now in there, I want to create a component. And we already did this. Actually, we got this out of the box in the app.js file by extending the component class from the React library. We can absolutely use this approach, and it will become more important later when you also learn about state, which basically allows you to change your component at runtime, you could say. But most of the time, you should use a different form of component or of creating components. A bare function, a simple JavaScript function. Because in its simplest form, a component is just a function which returns some JSX, some HTML, you could say. Now, of course, you can create a function with the function keyword. You could name it person, here with a lowercase starting character, which also is kind of a convention here. You could use a capital one though. And then you could return some JSX here. You can absolutely do that. You could also use the ES5 syntax of creating a variable which holds a function which in the end would result in the same. But I will use ES6 in this course, which I strongly recommend doing. It is kind of the best practice when creating React projects. It gives you access to many new and modern features. Hence, I will create a variable not with the var keyword, but with the const keyword, because I don't plan on changing this variable, effectively making it a constant, and hence we should mark it as such. I'll name it person with a lowercase character. As I said, you could choose person with uppercase p, but you often see the function name being all lowercase. It should otherwise be the same name as your file name though, or as the component name you want to use. Then I will assign a value to this variable, or constant to be precise, and this should be a function. Now I could again use function here, but actually I want to use the ES6 function syntax, this arrow function syntax. So I will say equal argument list arrow function body. This is just the ES6 equivalent to the function created with the function keyword. It holds some advantages, especially when it comes to the this keyword though. So I strongly recommend using this syntax. If this is brand new to you, now you know it, and in general, you might be interested in also diving into some ES6 courses or learning materials to simply learn about all the awesome features ES6 has to offer, like this one. Back to the syntax though. We effectively have a function here. And as I said, in its simplest form, a component is a function returning some JSX. So let's do that. Let's return some JSX. And we could simply return a paragraph here where I say, I'm a person. Now this alone creates a valid function which we could use as a component, but we also have to do two other things. Do you have an idea what we have to do? For one, we need to import React, because keep in mind, this JSX syntax is transformed to React create element. And to be able to call this method, we need to import React with a capital R from the React package, like this. So just as we do in app.js here. We don't need the component though, because here we're not using a class which extends component, instead we're creating a function. We still need to export that function though as the default of this file. Here we export this person constant which holds this function. With that, let's save the file so that this dot up here disappears and we only see the cross. And now we can start using this component in other files of our project. Namely, in the only other component, our root component we have yet in the app.js file. There, I will add an import, and I will import person. This name is now totally up to you, but it should be the name of your component starting with a capital character from /, because it's a relative path, the person folder, so referring to this folder, which is in the same path as the app.js file, and there the person.js file, though we can omit the .js because it's added automatically by the build workflow. Now it's important that you give this a name which starts with a uppercase character. You could choose any other name, it doesn't have to be person, though it makes sense to use the name of your component, but it should have an uppercase character. Because in React, in JSX, all elements starting with lowercase characters like div or h1 are reserved for the native HTML elements. So you could create your own component which you name div with an uppercase D. And then React could use that because it wouldn't interfere with the normal div. And for the same reason, you should give your person the uppercase character so that React identifies it as a custom component. So let's use person here, and we can either use an opening and closing tag like this, or since we don't nest anything between, I'll come back to that in the next lectures too, you can also use a self-closing tag with / and then the greater than sign at the end. With that, if you save this file too, and you now go back to your application with npm start still running in the terminal, you see I'm a person being rendered below our app component content. This is now coming from our own component, And if we inspect it, we see in the end, we don't see our custom element. We just see the paragraph we're exporting in that function, and that is actually how it should be. So this is now our own component getting used. Of course, using it like this is already nice, but what exactly is the benefit of creating it like this instead of simply adding the code right into the app.js file? Let's do more with this component to see that benefit in the next lecture. In the last lecture, we created our own component, the person component. The question is, what's the big advantage of this? Components are awesome because we can focus our code in each file and hence make it much more maintainable, not put everything into the app.js file, which can really get crowded for bigger apps. And this component is also reusable and configurable. Now I'll come back to the configuring part. Reusing it is quite simple. We can simply copy it and paste it as often as we want, maybe 3 times. And by simply doing this and saving that file, we get the output multiple times, and that is a super easy way of reusing it anywhere in our application. And if our application would contain more and more components, this would make it super easy to build it up with all these components and use them wherever we need to use them in our app. This is now effectively our custom HTML element. We also can configure it though. But before we do that, let's change something else about our React code. Because right now it's all static still. We have our custom component, but in there we still just have some static HTML text, some HTML content at the end. Now, oftentimes your templates, your JSX code should be dynamic, should output different things depending on the state of your application or on some user input. Now, we will do this a lot throughout the course, but let's lay the foundations for that in the next lecture. In the last lecture, we replicated the person component. Let's now dive into outputting some dynamic content in React. Thus far, we always hard-coded some HTML elements, and I'm always saying HTML, you know it's JSX, just because it looks like HTML, I'm saying that, and some text in between. Now let's say we want to say I'm a person, and I am X years old, but X should actually be a random number. Now we can simply do that. We can replace X with math random to get a random number between 0 and 1. Maybe multiply this with 30 and also use math floor to round it down. Now, if we do this and save that code, well, we see this output as a text, which makes sense. How would React know to execute this as JavaScript? After all, maybe we want to output it as a text. If we have some dynamic content in our JSX part, which we want to run as JavaScript code and not interpret as text, we have to wrap it in single curly braces. So let's wrap this in single curly braces, one in front of math floor and one after the closing parentheses. Now if we save this, we let this reload, we see I'm 0, 9, and 20 years old. And if we reload this again, we see different values because it's random. Now this is super important because this now shows us that we can output dynamic content as part of our JSX content. We can't define a JavaScript class in there or anything like that. We can execute one-line expressions, short, simple expressions like simple calculations or function calls here. That is important, by the way. I could call a function here, and this function might then do more complex stuff. We'll actually see us calling functions once we add event handlers. Now that we're able to output dynamic content, why don't we take it to the next level and make our component more dynamic so that we can leave outputting some generic content like person and a random number and instead do something else. Pass some configuration from the app.js file. Maybe some HTML attributes we pass to person to configure what we want to output for each usage of the person component. Now that we know how to output dynamic content, let's make our component configurable, flexible, and dynamic. For normal HTML elements, we can pass attributes, like class name, which we can add to any HTML attribute. An input element also would have the value attribute, for example. Now for person, it would be nice if we could say name and maybe pass max, and age and maybe pass 28. And for the second usage, we maybe want to pass menu and an age of 29. And for the third usage, we maybe want to use Stephanie and pass an age of 26. That's not my girlfriend, by the way. So if we do that, we want to output this. And maybe we even want to take it further. And for menu, we also want to split this in an opening and closing tag and also output some additional information like my hobbies, which could be racing. Now, with all of that in place, we have to change something in our person component to handle that input. Because by default, of course, if we save this and we reload the app, our output is unchanged. Because we're not using this information. How would we? How would React know what to do with that? Well, it actually is able to take these attributes and gives us access inside our receiving component on an object named props. Now actually the name here is up to you, but you will receive one argument in your function, one argument which is passed into it by default by React, which is an object with all the properties of this component. And properties means the attributes you add on your component. Now in React land, this is referred to as props, which is why I named this argument props, and I strongly recommend doing so that everyone else understands your code too. Theoretically, you're free to name this differently though. So now that we have props, we can get access to that name and age thing. So we could say I'm, and now use single curly braces to output something dynamic. I'm props name, and I am years old. Now here, I will keep the curly braces, but replace the random calculation with props age. I'm props name and I'm props years old. Let's now save this and let's see what happens if this now reloads in our application. If it doesn't reload manually. You should see I'm Max and 20 years old, menu, and Stephanie and all the ages. So now we're having the best of both worlds. We have a reusable component which has a clearly defined template, but in there we use dynamic content which we set from outside in the place where we actually use our component. This makes it really reusable. Think about all the possibilities which we will also explore in this course. Having an input component where you can set the type from outside. Having this person component which might be styled like a card to output dynamic or different content for the different persons. That is truly an amazing world of features we can access here, and it's one important step towards really building great and flexible components. What about the hobbies here though? Let's have a look at how we can use content which is passed not as an attribute, but between the opening and closing tags in the next lecture. In the last lecture, we learned how to use props, how to receive them as an argument and output them dynamically in our code. Now I also want to output whatever we pass between the opening and closing tag of our custom component. And this is actually super simple too. There is a special prop we can access React gives us access to it, to be precise. In the person component where we want to receive it in the end, I will wrap my paragraph in normal parentheses so that I can write this over multiple lines. Because I now also want to create a wrapping element, simply a div, and I want to wrap the paragraph inside of this div and also add another element after this paragraph. This other element should also be a paragraph maybe, but it should be a paragraph which outputs this part we pass in between. We can simply do that by using single curly braces to output something dynamic, accessing props, and then here the special children property. This is a reserved word. We didn't pass anything as children on our persons. We only pass name and age. Children refers to any elements, and this includes plain text as we have it here, between the opening and closing tag of our component. And you could nest complex HTML code in between too. This doesn't have to be just text. Could be an unordered list with multiple list items, could be other React components. Anything can go between here. And these children are now output with this syntax. Of course, you don't have to wrap it in a paragraph. You can use it anywhere in your JSX code. And after saving this, we see my hobbies racing for menu, whereas Max and Stephanie still output the other content only, because there we don't pass any children. If we inspect it, we see that an empty paragraph is rendered though. So the paragraph is there, it's just empty, because props children is basically undefined, is null, because we have nothing between opening and closing tag. This is important to know. You can put your content into your component from outside, not only by passing props like this, but if you want to pass some structured HTML content, also by placing it between the opening and closing tag and accessing it with props children. In the last lectures, we had a look at props. Props, simply an object giving us access to all the attributes we pass to our own components. Now, sometimes you don't want to get some information from outside, but you want to have it inside a component and change it from inside there too. So for example, here in our app.js file, let's say we also want to add a button, which if we click it, simply switches one of the names we use here. So where we simply put a caption of switch name maybe. Well, we'll come to handling this click event in the next lectures. But first of all, we need to define these names here in a non-hard-coded way. Right now it's hard-coded into our JSX code, and this is okay here. But if we later want to change it, we have to store it in some variable or something like that. Well, this actually is a class, and a class has properties. This is not just the case in JavaScript, but in other programming languages too. You can kind of think of a property as a variable of a class. So in normal JavaScript code, you would simply write var something equals some value. This doesn't work in a class. There, you can simply write something equals some value. So a bit shorter, but in the end, the same you could say. There's one special property you can define in any component which extends component. So you can't do it in person. You can't define properties here anyways, because that's a normal function. So here you would have to use some constants or some variables. Still, what we're about to do only works in components which are created by extending component. There we can define a special property named state. Whereas props are set and passed from outside, like name and age into the person component, state is managed from inside a component. Now important, this state property here is only available like this in components that extend components, so in class-based React components. Now actually, with React 16.8, a new feature was released called React Hooks, on which I'll have a whole module towards the end of the course, and which I'll also already introduce in this module here a little later. And with that new feature, you can actually also manage state in functional components. Now, for now, we'll not use that though. I'll talk about this in more detail later in this module. And therefore, we'll add state here in this class-based components, which is the default way of adding it. Still, you should use function components as often as possible because you should use state with care. Because having state in all your components and manipulating it from anywhere in your app makes your app quickly unpredictable and hard to manage, especially as it grows. Of course, it doesn't mean you shouldn't use it at all though. Here it makes perfect sense. We initialize it by assigning a value, and this value is a JavaScript object. Again, this is a reserved word, and we should use it if we want to manage, well, some component internal data, you should say. So now the state could have some persons. This is totally up to you. I simply create a persons property in this JavaScript object. And this will be an array. And you can set up any kind of data you want in this state object. You could set up a name property, which is some name. You can really manage whatever you want. Here I want to manage an array of persons though. Now this persons array again is an array of JavaScript objects where each object has a name, maybe Max, and an age, maybe 28. A number here, not a string. Unlike down there where we do pass a string, but a number is fine for me here. I also want to have another one here, name menu and age 29, and a third one, you guessed it, for Stephanie, which has an age of 26. Now this is my state. We can now access a property like this, and that's not just true for state but for any property, in our render method by simply outputting something dynamic with single curly braces as you learned it, and then the this keyword. This refers to the class due to our ES6 syntax we're using. And on our class, we have a render method we could call. We shouldn't do that though, React does that. But we have a state property. And as I said, you can also define your own properties, but state is a special one as you will learn over the next lectures. So here we can then access this state. And on state, my persons array, there may be the first element by using index 0, and then the name. So instead of hard coding it, I'm now accessing this property in this object here in the persons array on the state property. Now I'll copy this code here and replace my age with it too. There I of course want to access the age property. And I'll replicate this for menu, but here it's of course the first element, the second element with index 1 in this array. And for the age, I'll also access element 1 and of course the age property. And for Stephanie, you probably guessed that, index 2, and also for the age, index 2 and age property. With that, if we save this and we go back to the application, we see the button which doesn't do anything, and we see the same output as before. This time using a property, the state property though. Now, I said state would be a special property. Thus far, we don't use it in a special way though. We can change this. State can be changed, and if it changes, and that's the special thing about it, and it only works on that state property, if it changes, it will lead React to re-render our DOM, or to update the DOM, I should say. So if we change the name of Max here, for example, this will lead to this being re-rendered. And let me prove it to you by also showing you how to listen to events, like clicking on this button. In the last lecture, we set up state and I told you that it would be special, but we don't really see that yet. All we do right now is manage our data there and then access it in our JSX code in the app.js file. Let's now handle a click on this button. We do this by adding on click. Now this is important. In normal JavaScript and normal HTML to be precise, it would be on click with a lowercase c. Now in JSX, and that is really important, it's on click with a capital C. Still, we then assign as a value the code we want to execute upon a click. And there we can use curly braces to execute some dynamic code. Now, typically, you want to execute a function of your class, a so-called method there. And there's a convention to give this a name like the following. Switch name handler maybe. Now the first part, switch name, is totally up to you. But you typically use handler here to indicate that this is a method you're not actively calling, but you're assigning as an event handler. It's not required to follow this pattern though. You can name this whatever you want, of course. It is a good practice to name it like this though. So switch name handler now should be a function. Now if we just said equal, right now it is just the same syntax as for the state property. But if we assign a function as a value here, it becomes a method basically. It still is a property you could say, but a property which holds a function which can be executed. Here I'll also use the ES6 arrow function. Keep in mind, this is just a normal function in the end. And there I now want to edit my state. Well, before we do this, let's see if we can call this successfully. I will say console log was clicked so that we can see something in the console once this was clicked. And I will go to my click listener, and between the curly braces, I can now run this switch name handler, and don't add parentheses. Don't do this. This would execute it immediately once React renders this to the DOM, because you execute this function with the parentheses. We only want to pass a reference, and we do this by using this and then referring to that property which holds a function. Important. If you don't use this syntax here basically, where you assign a function to a property, you could say, you will run into errors if you try to use this, as we will soon do, in this switch name handler function, because this will then not refer to the class at runtime, simply due to how this works in ES5 JavaScript. By using this ES6 syntax, we circumvent this problem, which will become important later. For now important, don't add parentheses here, just pass a reference to this function. With that, let's save this file, and let's now open the console in the developer tools and click switch name. And you should see was clicked in your developer tools here. Now that's nice. Now let's also change the state. We'll do this in the next lecture. In the last lecture, we executed switch name handler upon a click. Now we want to manipulate the state upon the click. So I'll comment out this console log statement, and we could simply do this state, reaching out to this state property here. And as I mentioned, this will only work when using this syntax. Otherwise, this here will not refer to the class and will therefore not be able to reach that state property. But here it will work. So this state persons, then maybe access person 1 and set the name to Maximilian, my full name. Let's save this and let's see what happens if we execute this code. We already get a warning here, but let's ignore it for now and let's click switch name. Nothing changes, we still see Max here. Well, as I said, we do get a warning about this. We shouldn't mutate, which means change, the state directly like this. React will not recognize that and will not pick up this change. So don't do this. Instead, use a special method React gives you. You also access this with this, and then it's set state. We haven't defined this method, but remember that we extend component. And this is made available by the React library. And the component object happens to have a setState method. This is a method which allows us to update this special state property here, and it will then ensure that React gets to know about this update and updates the DOM. setState takes an object as an argument, and it will merge whatever we define here with our existing state. So if I here set persons to an updated array, it will merge this with existing data. So if we had some other state here, which is some other value, then this would not get touched even if we only update persons. Not clear what I mean? Let me show you. I'm copying persons and I'm basically adding this as a property in the object I'm about to use as my update here. So I'm saying this setState, and setState takes this new object where I update my persons, where I only change the first person, or maybe also let's change Stephanie. Let's change their age, her age to 27. Now, what it will do, what React will do for us, is it will look at our state and see which part of it we're overriding, we're changing, persons. It will not discard our state, but it will simply merge the old state with the new one. We'll override persons, since we clearly define a new version of persons here, but we'll leave our state untouched, because we're not saying anything about it here, and it will not discard it, which of course is a good thing. You don't want to have to update everything about your state whenever you want to change only a tiny piece about it. So with that, let's now see what happens if we save this file. If we save it now and reload the app, and I click switch name, watch Max, and watch 26 years old down there. You see that? It's Maximilian and 27 years. Now the DOM was updated because React recognized that the state of our application changes. And this really is a special thing. There aren't many things which lead React to update the DOM. There actually only are two: changing state, and what else? You could already see it in action. Props. We change state, that's nice. But keep in mind, what we actually output for each person is defined in this person component. And there we don't use state. And as I said, we could use it with React hooks, and I'll introduce you to React hooks right after this lecture here. But for now, we're not using state in here, but in our class-based component instead. Here we use props, and that's the other thing React watches out for. If state changes or props changes, it basically analyzes the code it already rendered to the DOM and the code it would now render if it were to re-render everything. And then it updates the existing DOM in all the places where it needs to update it to reflect your new state and props. New state in app.js, new props in person.js. In the last lectures, we learned a lot about state and props. And you learned that every component receives props, and that since React 16.8, you can also manage state in every component. Prior to that version, you could only manage state in class-based components. Now, either way, no matter if you're creating a component with the class keyword or as a functional component, if you are managing state in it, either with the state property and this setState, or with the React useState hook, no matter which of the approaches you're using, you can differentiate your components in stateful and stateless components. A stateful component is a component that manages state, no matter if it's using the useState hook or a class-based approach with the state property. A component like the person.js file, so this person component, is a stateless component because it has no internal state management. And it is a good practice to create as many of these stateless components, also called dump, because they have no internal logic, or presentational components, because they present something, they output content, they only get external data and output it in a structured way. It is a good practice to use as many of these stateless, dumb presentational components as possible in your application. These stateful components, so either class-based with state or functional with use state, are also called smart components or container components because they contain the state of your application. Of these components, you only want to have a couple. Well, of course, that depends on the size of your app. If you have an app with thousands of components, you'll also have multiple containers, so stateful components. But the idea is that you restrict yourself to a setup where you have way more functional presentational components than stateful components. Now, why? Because this makes your app easier to maintain and manage. You have a clear flow of data, and it's very clear where your main logic sits and where your data changes and then is distributed to the rest of your app. So if anyone, including yourself, ever needs to change something about the app, it's clear where to make that change. If every component in your app manages its own state, you quickly end up with spaghetti code where everyone is doing everything, and that can make your app very hard to reuse, to maintain, and so on. So have as many pure, functional, presentational components as possible, and only use state, no matter how, in a few selected components. And keep these terms in mind, because you will hear me say container or stateful or smart component for these stateful components in this course. And you'll also hear me say presentational, stateless, or dumb component, which means such components, of which you should have more than stateful components. So let's say we want to call the switch name handler, which I recognized also changes the age, so maybe the name wasn't chosen perfectly. Let's say we want to call that not when clicking this button here, or not only when clicking this button, but also, let's say, when clicking any paragraph here, the paragraph which contains name and age, inside a person component. Now for that, in the person component, we could add on click, but now what? We can't call that handler method, it's in a different file, in a different class. Well, we can actually pass a reference to this handler as a property to our component. And this is no fancy hack. This is actually a very common pattern. I will first of all restructure this over multiple lines for all these components so that we have an easier time seeing which properties we're passing. And then let's say I don't even want to pass this for all the components, but only for this usage of it. So here I will add a new property which I'll name click. And the name is totally up to you. Here I will pass a reference to this switch name handler. So basically what I also did here, this switch name handler on the click on the button, here I'm passing it as a reference to this click property. And now we can use this click property in person.js. There, I now can simply call props click, because click is the name of the property I defined here. And this will execute this function which I pass as a reference. So if we save all the files, app.js and person.js, we should see that in our application, we can of course still click this button to change the name of Maximilian and the age of Stephanie. But if I reload again, we can also click this paragraph with menu here. You also see it changed the name and the years. This is something important to understand, an important pattern. You can pass methods also as props, so that you can call a method which might change the state in another component which doesn't have direct access to the state and which shouldn't have direct access to the state. It's a common pattern and it's important to know. You can pass down click handlers which allow you to change the data in the parent component, in the app component in this case for the person component. Maybe we also want to pass a value to our function. Maybe here switch name handler should receive the new name. So that here, where I hard-coded Maximilian as the new name, I actually set name equal to new name. Now, how do we pass that data? There are two ways of doing that. The first is that you call bind. Here you may simply bind this. This controls what this inside the function will refer to. And by binding it to this here outside of the function, we're binding it to the class. Might look strange, but is a typical way of handling the this issue in JavaScript. We wouldn't have need to do that though, but we can use this syntax because I also want to pass a second argument to bind. This now is a list of arguments actually, which will be passed into our function. And here, this should be the new name. So here, this could be Maximilian. And to really see a difference, let's copy that bind code. And let's also bind it down here when we pass the function as a reference to the click prop. And let's change this to max with an exclamation mark here so that we can see a difference depending on where we clicked. If we now save this with bind added and this received as an argument in the switch name handler, let's see what happens if I click switch name. I'm still changing it to Maximilian here, which makes sense because this is what I bound to, but that it works confirms that it works with receiving an argument. And if I click on the imenu paragraph, you see that it changed to max with an exclamation mark. So this is a way of passing an argument. It's not the only way though. I will leave one of the two code snippets here with bind to show you how this works. I'll also show you an alternative syntax though. So I'll leave bind here where we pass it as props, but we could use this new syntax I'm showing you now also down there. This new syntax looks different. Here on click, I actually execute an arrow function, which takes no arguments, though theoretically it would receive an event object, by the way, but I won't use that here. And then simply as a function body returns this function call. Now here are a couple of things you have to understand. First of all, when using an arrow function, this implicitly adds a return keyword in front of the code which comes directly after the arrow if it's all written in one line. The alternative is to wrap this in curly braces and write a normal function body. So this gets returned. And what I return is a function call. This is why I added the parentheses. Now, in an earlier lecture, I said that you shouldn't call this, and that was true. But here, this is not getting executed immediately. Instead, what we pass here is an anonymous function, which will be executed on a click, and which then returns the result of this function getting executed, which of course simply leads to this function getting executed. This is useful because now here we can easily pass our data. Maximilian with 2 exclamation marks maybe. If I now save this and I click switch name, we see Maximilian with 2 exclamation marks. Now this is a very convenient syntax, but it can be inefficient. React can re-render certain things in your app too often. So I don't necessarily recommend using this if you don't have to. Use the bind syntax instead if you can. Still, I'll leave it here. You may use it, and depending on the size of your application, you also might not feel that big of a performance hit, but be aware that this can be inefficient. We covered a lot and we changed a lot of names here, but what if we actually want to change the name on our own? So let's say that in the person component here, we actually also have another element, a normal input element, which is of type text, and that's it. Should be self-closing. Now, whenever we type something there, we want to use what we type here as a new name. Now, for that, we can listen to a special event onChange. OnChange will be fired whenever the value in this input changes. And here I then want to execute some method, which I need to pass down from my app.js file. We got that switch name handler, and I will leave it as it is and instead add a new handler. I'll name it name changed handler. I expect to get an event object here. We haven't used that before. But in there, I still want to change the state. Now, of course, theoretically, you would want to change the state or the name of the person for which we typed this. This is something we'll do later in the course once we learned how to correctly render a list of dynamic elements. So for now, I will always change the name of Manu here. So Max will stay Max, and Stephanie should keep her age of 26 maybe even, but Manu should change its name, no matter in which instance of this person component I type. Again, this is something we will fix later. So here I will get an event, and as you might know for JavaScript events, this event probably has a target. The target doesn't make for a good name value though, but the target should be the input into which we typed. So it should actually also have a value property, which is the value the user entered, and therefore this now makes for a good updated value for name. So event target value is what I want to assign as a new name for manual, again for the time being, no matter into which input of which component I typed. Name changed handler is my handler. Now I need to pass this to a component to be able to access it from there. And since I only can change menu, I will only pass it to the menu person, though we could pass it to any other, of course. Here I will simply name this changed and pass this name changed handler, following the same logic as for the click event. Inside the person, I can now access this changed property and simply call props changed here. Or not call it, don't add parentheses, but simply pass the reference to it. And keep in mind, this refers to the method we declared in app.js, this name changed handler. The event object will actually be passed to it automatically by React, like a normal JavaScript, where you also by default get access to the event object. With that, let's save this and let's see what happens. We got inputs below all components, but for most of them nothing happens if I type in them. For menu though, you see with every keystroke the name updates, manual, whatever I want to type there. This is because we bound on change to this prop changed, which holds a reference to the name changed handler. And we then use this default event object to extract the target, which is the input element, and then the value of the target, which is what we entered. This shows us actually two things. How we can dynamically update something, dynamically call an event and use the things we learned before, like passing down event references or method references, I should say. But it also shows us how we can handle inputs. Now, it would also be nice if we would see the current value of the name in the input right from the start. So we basically want to set up two-way binding. When we change it, we want to propagate that change so that we can update the state. But we also want to see the current state right from the start. To do this, I can set value equal to props name. This is the name after all. And now we have our own two-way binding set up. We listen to changes, call the changed method in the end, which refers to the name changed handler, which updates the state, and we pass down the state to the person with name and age, and we output the name as the value of the input. This now allows us to show that value right from the start. And here I actually get a warning. This warning theoretically makes sense, because if you provide a value prop without an onChange handler here, you actually run into problems because you're binding the value to a property without allowing yourself to react to changes. Hence, you would lock your input down. I can show this if I remove onChange. Now you see we still see the values, but if I type there, nothing happens. I can't type because we're not handling changes. So we always override whatever we try to type with the existing name prop. If I reintroduce onChange though, the error stays here, which is simply a false alarm. As you can clearly see, I can type because I am able to handle my changes, update my state, update my props, and hence reflect my changes in the input here too. So we got a working two-way binding and we're able to change that name dynamically now. Again, keep in mind, only for manual because we haven't set up the logic for the other inputs, hence we can't type there because we can't update these names there. And that is probably why it's complaining here for these other inputs. For now, we can ignore this though. We will improve this once we have a better way of dynamically rendering a list of elements. We already learned a lot about the React basics over the last lectures. Our application still can use some extra styling, I'd say though. For example, these person components would be nice if they would look like cards and therefore be more like closed objects. Right now we can't really see the differences, or we can't really see the borders between this component and the other components. So styling components is obviously something super important. And right now there are two ways of styling we can implement. I will show you both. First of all, let's add a person.css file to our person component. And I gave this file the same name as the JavaScript file, just with a different extension. Of course, theoretically, that file name is up to you. Now, one important thing, whichever CSS code I write in here is not scoped to this person.js component. It is global CSS code. So I will define a new CSS class which I name person with a capital P. Still, I could add this anywhere in my application since it is global, but by using my component name, I can rule out the danger of accidentally using it somewhere else. So I will simply assign it to my div here. Class name, keep in mind, not class, class name, is person, a string person. Now, down there in the CSS file, I can now change the styling. Maybe give it a width of 60%, and a margin of auto to center it. Maybe also give it a border of 1 pixel solid EEE, a light gray, and a box shadow of 0, 2 pixels, 3 pixels, and a slightly darker gray. And let's give it a padding of 16 pixels maybe. Finally, let's set text align to center all the text. If I now save this CSS file and save the person.js file where I assign it as a class, nothing happens. Do you know why? Well, because we created our CSS class here in this CSS file, but by default, and this is maybe something you didn't know because it's not necessarily intuitive, but by default, no file is included into your project, into the code which gets created by the build workflow. You always have to import files to add them to the game. So we import the person component in our app.js file, and we also import the app CSS file here. Now it might look strange to import a CSS file into a JavaScript file like this. But thanks to Webpack, which is the build tool which is in the end used by this React scripts package we're using implicitly here, thanks to Webpack, we can actually import CSS into JavaScript, though it will not really merge the two files or anything like that. It is just made aware of that CSS file and will handle that differently. We'll basically import it into our HTML file. So in person.js, I will also add an import to /person CSS. And here you need the file extension. You can only omit it for JavaScript files. Now with that, you added this, you made Webpack aware of it. It will now add it to your HTML file. And hence, if you now go back, you see we have this extra styling on our components. You can also see that if you inspect your code, we have the person class here. And if you scroll all the way up to the head section here in the developer tools, you see that there we actually have these style tags, which you can't find in the HTML file in the public folder. There we got no style tags in the head section, just some links to the manifest and so on, so not even to CSS files. The reason for this is that these style tags are injected dynamically by Webpack. This is the part I meant with it manages the imports you add. And this last style tag here should actually hold your person class. And there you can also clearly see it's a normal global CSS class. You also see that automatic prefixing though, which is very convenient because it makes sure that we don't have to do that. We can write the shortest CSS code possible or needed, and it will automatically prefix it to work in as many browsers as possible. So this is the style we set up. Let's maybe fine tune it a bit more by adding a top and bottom margin here. So let's maybe set this to 16 pixels so that we have some separation between our cards. Looks much better. Now we got the persons here. Now let's also style that button, and let's style it differently because I mentioned that there are two ways of styling we know right now at least. In the last lecture I mentioned that we have different ways of styling the application. Let's style this button differently. In the app.js file, which is where we have that button, I want to style this button with something which is called Inline Styles. There's nothing wrong with using CSS files and classes, and this might even be the preferred way. But what you also often see in React apps is that you actually design your styles in JavaScript. How does this work? Let's go into that render function and create a new constant which I'll name style. The name is up to you. This is a JavaScript object, and as you might be aware, the CSS style properties have JavaScript representations. For example, background color, camel case instead of a dash, because background color like this would be an invalid JavaScript property name. You could wrap it in quotation marks to use it though. I'll use the camel case representation though. And then I assign a value, which is a string, which can be a color. For example, white. We can also set the font to inherit to use our surrounding font. We can also set a border, not border color, just a border of 1 pixel, solid, and then maybe blue. And we could also add some padding, maybe 8 pixels. Make sure to wrap all these values in quotation marks because we are writing JavaScript here. These have to be strings. Now I can go to the button, put on click into a new line to make this a bit easier to read, and add a style property. This is actually the normal style attribute made available by JSX. And style, as you can already see, should receive a dynamic value here. I'll simply pass style here, referring to this style constant, which is defined in the render method, of which this return expression here is part. So I can't just use style like this. It's not a class property, it's a normal variable, or actually, since we never change it, constant of this render method. Let's see if this has any effect. If we save this, we indeed see the button looks different now. We can improve this a bit more by first of all fixing this error and have 1 pixel of a border so that this style gets applied to, and setting the cursor to pointer so that we get this pointer cursor when hovering over it. If I now save this, we see that blue border and we see that cursor again. Now it doesn't change upon hovering, and actually styling that hover effect is pretty hard when using inline styles. This is one restriction already, but I got a whole module in this course where I show you some clever solutions to styling React components, which really can be something you can put a lot of thought into it. Always be aware, you can use a CSS file though. Then the styles defined here are global. So if we change button here, all the buttons in our whole app will be changed. So this might not be what you want. But on the other hand, you can use the normal CSS syntax. Or you use inline styles as you do here. Then the styling is scoped to the component or to the element you actually added to, but you have some restrictions of not being able to leverage the full power of CSS. As I mentioned, I'll have a full module about this because there is a golden way in the middle where you can scope styles and still use all the CSS features. More about this later. For now, be aware that we got these two different ways of styling at the moment. Use inline styles as we do here whenever you want to scope the style and make sure it only applies to this single element and to none other element in your app or even in the same component.